In EKG, how do electrolyte imbalances affect your EKG reading? Well, let's start with calcium and potassium. As your potassium levels increase, so does your T wave. And as your potassium levels decrease, so does your T wave. Some people call this the push-pull method, meaning as your potassium levels go down, like in hypokalemia, it pushes that T wave down as well. And in hyperkalemia, as your levels elevate, so does your T wave. It pulls your T wave up, giving you taller peaked T waves. But what about calcium? As your calcium levels increase, it tightens up your QT interval. And as your calcium levels decrease, it elongates that QT interval. But let's see what that looks like. During hypocalcemia, your QT interval gets long, and the opposite happens during hypercalcemia, where it gets shorter. But why is all of this important? Well, when you have long QT going on, it makes you more susceptible to ventricular arrhythmias. And when you have a tight, short QT interval, it can sometimes be mistaken as a myocardial infarction, which you would treat very differently than hypercalcemia. Now, people ask why this affects your EKG readings, and a lot of it has to do with your action potential. During phase 3 and phase 4, which are repolarization, potassium and calcium are huge players.